Всем привет. Меня зовут Александр Лугов.
Hi everyone, my name is Alexander Lukov.
Так, сейчас. С 2021
I work
года.
in K2 Cloud since the year 2021. I'm a chief engineer in information security.
Какой кликер? Значит, K2 Cloud. Ранее мы называли скрок-облачные сервисы.
So K2 Clouds, we called ourselves the cloud services when we work in B2B segment, providing services to meet and size a big business. For cloud platforms. We have been developing the platform since 2009, and the core of it is hypervisor KVM, along with QEMU emulation mechanism. Today, I will cover why resource isolation in clouds is so important. What are the risks when you violate this isolation? And we'll talk about mechanisms which implement VM's isolation, the rights of access and the storages. Also, a little bit about delineation of responsibility, what cloud provider is responsible as opposite to the user, and also give several recommendations about how to make sure that your cloud would be safe. Well, today we are going to go to this great voyage with a bit. It's a little guy who wants to live in the cloud, and the goal of this travel will be to go through all the key isolation mechanisms so that this bit guy would understand it. Is everything right? You can trust the most sensitive data to your cloud. But before this bit guy is going to move into the cloud, he has to understand that even the most protected infrastructure may have some vulnerabilities. And then you appreciate not only the importance of isolation, but you need to know where it would be crucial to do this, and what are the typical risks if we violate principles of isolation. Lately, we've heard attack like Meltdown and Spectre. They're using the sideway channel and backing up the cache and instructions to be able to go beyond the memory isolation and to get access to others' members. Then breakout attacks when the attacker is trying to get from the beyond of the virtual machine to be able to get access to the host or other virtual machines. Anyway, the absolute majority of the incidents with the data leaks in the clouds happens not due to some complex attacks, but due to just common mistakes of configuration by the users. In part, the rules of the firewall are, anonymous buckets and super administrator rights violated. Also, we can identify another type of risk: is very noisy neighbors, where the work of one virtual machine can have a negative impact on other virtual machines. For instance, if there is a DDoS attack on one machine, the platform should kind of isolate other machines from that. All these risks are combined, that if isolation is not enough, then this is a systemic risk. And if between the VMs and the networks and storages will not be clear barriers, then attack on one system can be spilled over to different subsystems. So resource isolation is not just additional measure of security. Reliable isolation is a foundation of security, and this is why the bit guy can be sure that if something is going to happen next to him, his data will still be safe and sound. So the travel of the bit guy happens when the user or an organization decides to move their data into a cloud. It could seem simple. We choose the image of the OS, we need resources, and push a button, create a virtual machine. But frankly, this seeming simplicity hides a very complex mechanism which sets the set of hardware into automated infrastructure. Just imagine that all the virtual machines in the cloud are like separate apartments in a big multi-family building. So layout would be the image, the number of kernels, operational memory, and also the cloud platforms is basically choosing a physical server and And for the bit, for this little robot, it's like a new empty space, and this is the first isolation. The virtual machine works in its own space. But if there are many virtual machines operational, it's critically important to isolate their resources. And here, hypervisor KVM is playing its role, which is the module of the Linux kernel. And through the hypervisor, the virtual machines address two physical resources of the server, for example, processor, operational memory, and input-output devices. And hypervisor builds very reliable barriers between them and supervises resource allocation. But the magic happens not on the level of software, but on the level of hardware. In processors, specifically. Modern processors support a technology of hardware virtualization. For example, in Intel, there are VTX, and this technology ensures that instruction of one VM would be executed and isolated from the other VM. And also EPT, this technology ensures that the virtual machines will be able to read physical memory pages which have been dedicated. So hypervisor of KVM, with using hardware virtualization, not only controls resource allocation, but also consumption, but builds reliable barriers. Just a second, I want to take my water. Just had my mouth dry. Moving on. Hypervisor with a hardware virtualization sounds great, but for comfortable existence of the little robot, that's not enough. It's important for the host operation system, controlling resources for virtual machines and distributes those resources between them. At this stage, we're going to look at how Linux operational system supervises resource consumption by processor, operational memory, subsystem disks between different virtual machines. Begin with the process. When a user creates a virtual machine, they set a certain number of virtual kernels, vCPU. And numbers vCPU means like how many operations in parallel a virtual machine can perform. A limit of vCPU would be the upper threshold of how many resources a processor can consume. But what if a virtual machine is just a one virtual kernel and it's loaded 100%? Then the platform has to make sure that it would not consume more resources than it would be allowed for the whole physical kernel. There's a C-drops mechanism, and this mechanism enables you to set limits for consumptions of processor time by the processor. In reality, that we use soft and harsh limit. The soft ones for the flexible control of resource consumption, and the hard limits for micro instances that they would not take more resources than allowed. Now, operational memory. With launching a virtual machine via QM emulation, we reserve a certain volume of operational memory for the VMware, for example, 8 GB. And hypervisor KVM is responsible for the borders with hardware virtualization and huge pages tables. We also use another technology, mostly for performance. It's a huge pages. This technology, huge pages, dedicates certain memory on a server and creates big memory pages. It is in this field that we place operational memory for VMs, and they can address faster to the server memory. But using this stack enables us to do yet another layer of isolation, which isolates the memory for virtual machine from the memory under the host needs itself, because it uses just a regular small memory pages. When in a cloud, we create a disk. Depending on its type and specs, we assign a limit of performance, for example, 500 IOPS. That means that such a disk cannot do more than 500 operations of reading and writing a second. If it tries to overstep the limit, then there's a bit in QM, a throttle filter. It stops the requests of the bit, puts them in sequence, and doses them so that limits would not be overstepped. But thanks to this mechanism, bit can be sure that his disks are going to work with expected performance, but the neighbors will not affect this performance. Next, bit robot is moving along the network, but as any self-respecting digital citizen, he wants his traffic to be confidential and immutable. So we use very strong program of the SDN tool, and on the basis of the OpenVSH OVS, OVN and OVS. When we use SDN, we are not making physical links, we're not do the manual setup for the hardware. SDN automatically applies all right configurations on a hypervisor and begins to connect in virtual machine to the network, and all the way until setting the rules of firewall restriction. When the bit robot traveling from one VM to the other VM, his packages are being encapsulated and sent on the along the network to the other hypervisor with the nginf protocol, in the tunnel of which there is an but I'll share about that a bit later. When the bit robot begins to pass on data within its logical network, first of all, he ends up on the logical switchboard, basically. And in the port of this virtual switch, there's a virtual interface is connected, and OVN applies rules of network ACL, and it's tracing communications. For tracing communications, we are using built-in interlinks contract mechanism. And due to this set of technologies and at the logical router, we use the service of the group of safety. This is the firewall, and in a stateful mode, it's the final end used by the client. When the users begin to pass on, or bit begins to pass on data into other subnet or beyond the cloud, it's end up on the logical router. And in the port of this logical router, we've connected the port of logical router. And this OVN also overlaps the ACL or rules of filtration. But in this case, it works on the stateless mode. And at this level, these mechanisms implement service code and network ACL used by the users for traffic filtration on the level of subnets. When the traffic goes beyond the cloud, it goes through NAT, all the outbound traffic use source node and destination NAT, but only when the virtual machine definitely assigned a public IP address. It helps to obfuscate bits addresses. Let's see additional some mechanisms or key mechanisms of security and control. First of them is port security. It's a mechanism built into OVN, which creates rigid limits for permissible MAC and IP addresses in the network interface. That means if a VM virtual machine will decide to change its IP address and pass on data, this data will be rolled back onto a virtual switchboard. So this is the defense of the outgoing spoofing attacks. The next would be source dest check, another control mechanism setting the harsh limitations that all the packages going through the network interface, they gotta be either addressed or have to be generated by it. In practice, virtual machine cannot work in the mode of like router or proxy. This mechanism is working by default for all interfaces, and if the user needs a virtual machine to work as a proxy, they have to switch off this mechanism in the interface of their platform. Next, I will consider important mechanism, virtual network identifier. And this identifier in the Geneva tunnels, and also because of that, Beat robot can be assured that its virtual network are going to be isolated on a logical level from the virtual network of all other users and will not be mixed up even when passing along the one or the same physical network. Every proactive journey, the Beat robot has to stay for taking a rest and taking a nap, and he has a right to choose. In the cloud, there are two type of storage: block and object storage. Block storage used within the virtual machine, and the object storage is used for storing archived data, blocks, and backup copies, for which it's critically important to be reliable and to be scalable. For both types of storage, we use the program-defined storage, or SDS. SDS is responsible not only for dedicating a certain number of disk space, but also responsible for the good isolation of bit data from the other users' data. Let's see the block storage. When in SDS a disk is created, we set a certain volume. This volume becomes available within the virtual machine of the RBit character, but physical blocks are filled only as much as bits would be writing data. After creating a disk, he, using special drivers, is connected to hypervisor, where bit plans to launch a virtual machine. And later, the cloud servers with a special protocol of QMP management address the process and say, can you connect this virtual disk to your virtual machine? And after which the bit guy inside of his virtual machine can see this disk as just a regular block device like DevEDA. If the bit does not have to work with active work with disks, they can find the object storage. In object storage, all files are stored in buckets, like folders, but without inserted structure. And addressing the buckets happens by the access key and secret key. All inquiries are signed up and double-checked. The access control is two-level. IAM politics, they decide who and has access to what. And bucket policies, they define what can be executed with this bucket, what can be done with a specific object in the bucket, and from which IP addresses. And also you can use additional mechanism of protection, object lock. This mechanism, in a very tight regime, can forbid data deletion from the bucket until a certain time is expired, even to the owner. Even owner cannot do that. And also server-side encryption, which is encryption on the side of the server, meaning that when writing into a bucket, the files are going to be encrypted, and when read, they'll be decrypted. So it helps us to contain the risk if the storage will be compromised. When we need to delete something in the cloud, in the object storage, RGB. Before deletion, the file is placed in a special basket and not accessible to the user. And then there is a certain trash collector is being launched, which is deleting fragments of this file from the physical nodes of storage. In the block storage, when deleting a file, its area is placed as released, and if somebody will try to read it, then always it will be getting just zeros. So even if it'll try to read it, then it won't be able to restore any data. It is happening due to the lack of mapping in the SAP RDB for these data in released kind of areas or space. Now, having considered all these mechanisms, the Beat robot understood that throughout his life cycle from creation to deletion, his data are safe. And so the Beat robot got to his virtual machine. He traveled along the virtual network, he placed his stuff in a storage, but then he thought about who can come to his house, who can knock on his door, and who can come without even knocking. We can answer this question having one of the most important services, IAM, or Identification and Access Management. This service is not just a list of users. It double checks a user, identifies whether it's legitimate, and its a right of access. All of this happening under the certification and roles. They're like, no, let me try, or let me just see. No, this is not going to pass. So when somebody is addressing the cloud, firstly, it met by the authentication service. It double checks like who is addressing, and also double check that this is really, or basically its identity. This service would make the forge impossible because it knows who owns what keys. It uses session keys to the users and signed up all the inquiries. Double checks them to exclude compromise, and the secrets are safe with this system. After this identification and authentication have been passed, authorization verification kicks in. So it is critically important to keep the rights and principles of the least privileged rights. A cloud platform provides a role-based model like roles and policies. It's important for the users to be able to fine-tune them for themselves, and in such a way that the system admin would be able to build and delete virtual machines, or a network engineer to manage DNS and backup agent, do only backup copies, and an InfoSec guy to manage users only. No using of credentials by super administrator. And for reliable access, it's good to use multi-factor authentication when we're using several independent factors for entry. Number one, for example, what we know, login and password, and secondly, what we have, for instance, one-time code. And because of that, even if the password is going to be leaked, probably attackers won't be able to use it, and in this way, the security of access is going up by leaps and bounds, which is important for admin privileges especially. And sometimes you want to manage users in a centralized way, especially in big companies and organizations. So Kata Cloud has integration with external providers of certificates. That means that users will be able to authorize in the cloud with their corporate credentials. Oftentimes, the external providers would be Active Directory of Katelog. So having used people to this Active Directory, they'll have the access rights in the cloud, and vice versa. If you delete them from the group, they will lose this access from the cloud. Having studied all of these mechanisms, the Beat robot understood that a cloud will let only those who got permission to do so. So the Beat robot has learned what the cloud is about. He knows that the technical protection tools are operational, but then he thought, is it true that that security is ensured by the cloud provider himself? Because if the user will leave the door open, then no protection devices and tools will be efficient. Thinking about that, he began to deliberate what cloud provider is responsible for, unlike the users. And we can get answer with the typical metrics of the responsibilities delineation. If you take this matrix and project it to what we've just discussed, then we will get the following option. Delineation of responsibility. Cloud provider responsible for physical protection of data centers, 24/7 video surveillance, security, non-stop feeding, cooling, power, and the good hardware, including the virtual or hardware virtualization, microcode, and the firmware upgrade, and for the safe hypervisor and tools of virtualization, that they are developing network barriers which are implemented by the cloud platform. It should be operational, and should be operational in a reliable mode. I mean, all firewalls should filter the traffic, and the bits should not be mixed up. The storage should be safe and also to be deleted in a safe way. It is also important for the provider to comply with the best practices or national or international security standards. Now, what is happening within the zone of responsibility of the user? They are responsible for how they will be using what cloud platform provides and for their own resources, meaning that users have to turn on multi-factor MFA, that the platform provides, to set access role model for their own needs. And OS in applications working within the virtual machines should not have known vulnerabilities. They should be upgraded. And also users have to control rights of the firewalling. There shouldn't be like all extra ports open and the backup copying of the data restoration, making sure that these are working backups also should be within the scope of the users. And also using the other services also should be within the user's responsibility.
So, the cloud provider is building the cloud platform and provides for its security, and the user is taking care of the security of the system that it hosts there. And only the joint work of these two sides provides a safe environment for BIT, so that they shouldn't worry about attacks or leaks. In order to improve the security and safety of BIT's home, certain steps can be made. The cloud platform can mandatorily enable multi-factor authentication for all users. As I mentioned, it's very important to observe the least privilege principle, so that the user shouldn't be using standard roles offered by the cloud platform. It's important they adapt them for their needs. For the automatic control of configuration, the user can use the cloud API together with both their own scripts and some automation tools. It's important that the user should regularly verify the infrastructure for vulnerabilities, because vulnerabilities are potential holes through which the bad guy can get into BIT's home. Also, the cloud platform offers a lot of useful services, such as monitoring, action log, backup. It's important that the user should use them and use them with quality. So the user and BIT have taken care of the security and safety of BIT's home. But they may have a question: is the cloud provider caring about their security or its security as well as them? BIT can't enter the internal systems of the cloud platform, but it can try and assess the maturity level. For this, they can check which national or international standards the cloud platform is certified to. One can take a look at the classic standards such as ISO 21013, but I would rather suggest that you check such technical standards of like GOST 57580, PCI DSS, ISO 27000, or Federal Law 152. These documents offer hundreds of requirements, just as GOST standards sets more than 400 requirements. It's important for BIT that the cloud platform should not just comply with this audit, because security is a variable for business. It's important that it shouldn't just be observed once. It should be a process. To check that, BIT can see when was the last time that the cloud platform has passed the audit. It should be mentioned in documents. Also, so they can assess the openness of the provider, where they publish data on their website or they publish on request what they're saying in general, how they behave in personal contact when questions like that are being asked. I've already mentioned these things in my paper on Harbor, to which we have the link here, and those of you who are interested can try and read it. So now BIT can believe that they're home. They know that there are lots of reliable technology tools that isolate their data at the level of virtual networks and storage. They know that security is something that works both ways. And so the platform is responsible for their part, and they are responsible for theirs. They trust the cloud. They know that it will cope with their requirements. Most importantly, they're happy and calm. Thank you for your attention. I'm hoping I've shared something of interest to you and useful as well. I'm prepared for questions. Okay, then. Thank you very much, Alexander. Yeah, we got some questions. So this book will be for the best question. I saw that the user responsibility includes protection from DDoS attacks. It's a well-known fact that DDoS attacks are installed on the provider side, whereas to drop the user, to drop the DDoS traffic at the user PC is not going to work. It won't help the canals. Maybe that was just a typo. And what the user in principle can do about DDoS. So Megaphone and Rostelecom tries to give some statistic, but it's the SOC who are responsible for DDoS. What's your take? It's a good question. Well, actually, the responsibility matrices. Most of these responsibility divisions work quite often as a joint activity. The cloud provider, so what fits within their responsibility, they must protect those public resources that they're offering to the user. For instance, the cloud platform management console, API endpoints, or any other public resources. It's up to them to protect them, because DDoS attack at them will affect all users. It's fully their responsibility. If the attack is targeted at the user's VM, protecting from it is the user responsibility. So the attack kills the provider link, and what? So there's a terrible bit of traffic coming in, I drop it. So it's a question to the architecture of the cloud platform as such. The cloud platform has tools to mitigate this impact. How does it look? For instance, user one says, I don't want to pay my money for DDoS protection. So if they want to DDoS me, okay, I won't be doing anything. And if nothing is done, then indeed this can affect other users. There are different mechanisms that will disable the channel, and the DDoS attack will not affect other users. Another situation is where the user says, I'm interested in DDoS protection. There can be different variants. There could be a third party, like a SaaS device, or even a hardware solution. If it's a SaaS in the cloud platform, this indeed will be joint responsibility, so that the cloud provider should guarantee this protection. But if it's a third-party solution, then that would be the responsibility of the end user and the third-party provider. So it may happen quite often in SaaS, but if the user has a dedicated IP address, it's clear that that would be a special case. But as a rule, they attack the whole networks, and the attack goes for the provider as a whole. Well, actually, from our experience, quite often, more often than not, the attack happen targeted at a specific IP address. Like, for instance, in the beginning of this year, they were attacking everyone. And in that case, of course, we took it up ourselves. We enabled protection for all the thousands of addresses. Well, in our case, they usually take all the autonomous connection and attack them as a whole. And with a large volume, channels of quite large operators are being affected.
Yeah.
Well, you're right. In our case, the typical cases are usually different. Okay, there was another question. Can you please pass the microphone to that person? And I see other question as well. My question is about the reliability of CEF and the RBD solution, replacing the classic scheme with storage and server nodes. As if we're talking about CEF, as I understand, we're talking about the system spread over multiple nodes. How realistic it is that it will really, spread, really go down. Can it be recommended for a serious enterprise customer as a replacement for a storage system? As far as I know, CEF is used broadly around the world. But I mean, can it just disassemble because of some network problems? As far as I know, it wasn't only CEF, especially earlier. The key thing, well, the key answer is that you, as in that joke, you just need to know how to cook it. Some commercial solutions may be simpler and more reliable. CEF, I mean, the free CEF and the paid CEF, it requires more competencies. So I think it's more about that. So if you set it up correctly, it won't. Well, we work on it, and we're not alone. We work on it, and we're far from being alone. It's quite a viable solution. So you can give up on data storage systems. And, well, I can't, be that specific. On the whole, that may depend on the specificity of a specific environment. Maybe storage service could be more applicable to some situations. But it looks here that the server gets direct access to the physical disk without this long channel. The interfaces, the links, then this storage rack. Well, by the way, no, I think we don't no longer use CEF for that, for this new type of storage. Well, if you are interested in deep technical details, there are my colleagues in the room who know CEF and the technology very well, and you can talk to them. Okay, we're posting this question offline, and another colleague had a question. Can you please bring the microphone? So it's CB, Sergei Antikov. Two questions. You ran an audit of the system to GOST. Weren't you thinking of running a fully fledged certification to comply with STEC 21? Well, we have certification to STEC 21. We have certification to comply with GOST 871. Recently, we ran it for the second time. Last year, we had had all 9.2 for the first level of security, and today 0.94. With SCISS, we have been running certification for many years now. So it's done through an independent accreditation party. We always run all certifications on the top level of security because our users are major businesses and they have a major security requests. They need to comply with the top requirements. In terms of division of responsibilities between the user and providers, antivirus, is my understanding correct that the user install it on virtual machines and on servers you have it yourself? Yes, of course. All such measures in all these standards are passed separately by the provider and the user. As part of the certification or compliance verification process, they also need to use antiviruses and some IPS and firewalls. So the exclusion is that normally the provider publishes on their website a matrix of responsibility division specifically for these things, for personal data, separately for GOST 7800, where measures are listed explicitly and it is indicated which measures are the responsibility of the user or the provider. So the user don't need to do anything. So they show this matrix to the auditor, and auditor says, okay, it's not applicable to you. And it's all mentioned in the assessor's report. Yes, it's a matrix of responsibility division for each of such audits. We are publishing them on our website. Thank you very much. So thank you all. Alexander, thank you. Let's give him a round of applause. That was an exciting presentation. I was listening and thought that if you turn it a little bit more human, you could read it to all school children. Well, I was trying to make it human. Okay, whom do you award the question? I think the last question is a good fit.